Now the two examples at the top of page 2 are examples of linear inequalities, and they're simple linear inequalities. Basically, in these examples, we can treat them exactly the same as we treated equations before. So, to solve this equation here, the inequality, I should say, this inequality 4x minus 2 is less than 18, what we've got to do, first of all, as if we had an equation, we've got to add 2 to both sides. So if you add 2 to both sides, we will get 4x minus 2 plus 2 less than 18 plus 2. That simplifies to become 4x is less than 20. And then we can divide by 4 to get 4x over 4 is less than 20 over 4. And finally, 20 divided by 4 is 5. So we have x is less than 5. If you want to graph that, the solution there would be starting at 5, and then it would be everything to the left of that. Now just try to remember, should we have a full circle or an empty circle at 5? If it's less than, and there's no equal symbol, then it has to be an empty circle at 5. And in example 2, it's another linear inequality. The first thing to do, we want to get all the x's on the same side. You could have them all on the left-hand side, or you could have them all on the right-hand side. If we subtract 2x from both sides, that should mean that we get all the x's on the right-hand side. And then if you want to get rid of that negative 21 there, we've got to add 21 to both sides, and that gives us eventually, so that gives us 24 is more than or equal to 3x. We've got to then divide both sides by 3. If you simplify that, that becomes 8 is more than or equal to x. And if you wanted to write that in its more usual form, notice that the x here is another way of thinking about this is that 8 is more than or equal to x. In other words, you could think of that as being x is less than or equal to 8. Now just remember, if it's x is less than or equal to 8, then if we're doing the graph of the solution over here, what kind of circle will that mean that we need at 8? Well, it should mean that we need a full circle at 8. And that's what we have here. Remember the arrow pointing on towards negative infinity over there.